Hello, this is Claire and I'm going to talk to you a little bit about the introduction to trigonometry. And this is a very exciting study and it has many uses. So the three trig ratios are used in a right-angled triangle, and we're going to start off just looking at those three trigonometric ratios. So if you could draw a right-angled triangle, please, with your ruler and indicate the right angle. Now, opposite the right angle is the hypotenuse, and we've already talked about that in Pythagoras, so it's still called the hypotenuse. So let's label it H. H for the hypotenuse. Now, there are another two sides and they have labels also, and they are labelled because of their position, their proximity to a given angle. So let's consider this angle here. Let's label it an unknown size and we'll call it theta. So we use Greek letters often to indicate the size or the magnitude of an angle. So we're going to talk about this angle in this right angle triangle, and the two sides will be labelled in proximity to this angle. So opposite, the side opposite that angle is over here, and that's called the opposite side. So it's simply O for opposite. The third side is next to the angle, so it's next to the angle, and we call that adjacent to the angle, so it's A for adjacent. So we have the opposite side because it's opposite the angle we've been given. We have the hypotenuse, which is opposite the right angle, and the other side is adjacent the angle we've been given. So they're the side lengths that are used in all our trig ratios. So we'll just look at this other triangle I've constructed here, and this time the angle in question I'm going to put up here, and we're going to call it alpha. So there's alpha. So we often use these Greek letters, alpha, beta, theta, phi, as the magnitude of different angles in a triangle. So it's traditional. So now we still have the hypotenuse opposite the right angle. So it's always label your hypotenuse first, and it's opposite the right angle. It's the longest side in the triangle. Now the side length opposite the angle you've been given is called the opposite side length, and the other length, which is not yet used, is the adjacent side length. Adjacent does mean next to, so that is the adjacent the given angle. So the side lengths are purely labelled because of their proximity to the given angle. So let's have a look at what those ratios are. There's three ratios. The first one is the sine ratio. So the sine ratio is written as the sine of the angle, sine theta. The sine ratio is the ratio of the opposite side length over the hypotenuse side length. And that is the name of the sine ratio. It's the ratio of the opposite side length over the hypotenuse side length. And the combination of those two in a ratio form is called the sine ratio. And the sine of that angle, because the opposite is in relation to the angle that I've been given there, theta. So the next one is the cosine ratio. So the cosine ratio is the name given to the adjacent side length over the hypotenuse. So we call that cos theta is the adjacent side length divided by the hypotenuse side length. And the mixture of those two side lengths in ratio is called the cosine ratio. The last one is the tangent ratio or the tan ratio. Let's write it up here. So the tangent ratio, you've heard of the word tangent. We've been talking about tangents in geometry, and it is related to that. So the tangent ratio is the name given to the opposite side length divided by the adjacent side length. So we call that the tan of the angle theta is opposite over adjacent. And to remember those, we use SOHCAHTOA, and that's just a technique to remember them. So SO, the sine of the angle, is the opposite over the hypotenuse. CA is the cosine of the angle, is the adjacent over the hypotenuse. And TOA, T, is the opposite over the adjacent. So sometimes it's written like this. I find that quite handy. Or you may see it written like this also. So, SOHCAHTOA. I find this one slightly better because it helps you remember that they are over each other. So the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and tan is the opposite over the adjacent. Notice there's no hypotenuse in the tan ratio, but the hypotenuse is in both sine and cosine. So that's just how to label those side lengths, and it's very important to get some practice labeling those side lengths before we continue on. So I'll see you in the next tutorial where we are going to show you some of the features of the trig ratios. So I'll catch you then. Bye for now.